So, okay, guys, we start with the topic of current electricity. This is the day 21st of our Utme and SSE examination prep. So now we are starting with the first question. I am Engineer D. And if you find anything interesting, like I do say, you can consider subscribing to the channel. Now, the first question here is a quantity of electricity is measured in the unit of dash. I think we have talked about that under capacitors and under electrical cell. We say quantity of electricity basically is given under electrostatics to talk about quantity of electricity. Say quantity of electricity Q. Sorry, guys. I want to reduce the size. Is given as the current multiplied by time, which you have also studied in chemistry, according to Faraday. So this quantity of electricity is measured in what we call coulombs. Coulombs. Please keep that at the back of your mind. So coulombs, which we've talked about, I don't think we should waste time on this. We can define each of and every one of these. We can define what we call electromotive force, EMF. EMF is defined as the potential, EMF is defined as the PD, potential difference in a circuit. I'm just giving you a good definition for quick concept. When the cell or when the circuit, when the cell, that's the battery, is not delivering any current. So this is the definition we give to potential difference in early classes. So always keep that at the back of your mind. It's very, very important. Now, another thing you can also keep in mind because of definition, you can say the total work done, the summation of work done. Because I've seen a lot of situations whereby students don't know the difference between PD and EMF. Total work done in moving. You're talking about the amount of energy in moving an electrical current or in moving a PD, a potential, I said electric current, sorry, a PD around a circuit or around a circuit. So please, that is the definition we give to EMF. In fact, we have talked about, we said V, which is V is equals to current times internal resistance. When we talk about electrical cell, we say the PD that is flowing in and what in our cell is current times internal resistance, the resistance offered by electrolyte. So my point is, in a circuit, V is equals to current times what? Resistance. This is Ohm's law. Now, Ohm's law is always valid. I'm just taking quick concept, and like I do say, quick concept, maximum in depth of knowledge in minimum possible time. We say the current, the voltage is always proportional to current at constant temperature. So this we call Ohm's law. When we talk about circuit, cell is talking about battery. So whereby this is Ohm's law, because a lot is to be said. Ohm's law. V is proportional to I. So when you draw the graph of V against I, for all metals at constant temperature. So when we draw a graph of what V against I, the graph is always going to be a direct graph. Please, it's going to be a straight line graph. So anytime you plot this graph of voltage against current, it's always for metals at constant temperature. That is the validation of Ohm's law. So like I said, your own kind of current electricity according for O-level students is so simple. So you don't need to know too much of things. They are just the basic aspect of current electricity. And keep it at the back of your mind that current is a scalar quantity. I hope I'm talking to you guys. Current is a scalar quantity. So always keep that at the back of your mind. Current is always a scalar quantity. Now, we also define something we call current density because of new pattern of question. Why I'm doing this is to help you guys to score very high. Current density. Now, current density is the vector form of current. It is denoted by something like J, like this. Is the what amount of current that is flowing per unit area. Please. Amount of current that is flowing per unit area is called current density, and this is the vector. So be careful about current and current density. So current is scalar, current density is vector. I hope I am communicating, and if I am, so like I said, there are limitations to Ohm's law, which is also important. So limitations to Ohm, there are a lot of limitations, but we talk about important one for your level, that is that does not obey a direct graph. That is that sets what? That sets what? The extent. That is the extent at which Ohm's law can work. A lot of them, we have diodes. We have semiconductors. We are still going to talk about this topic, so I'm not going to rush you. Just keep it in mind for now. We have electrolyte. All these don't obey Ohm's law because their current against what? Against voltage is not always a direct graph, and that is why we call these, amongst others, as limitations to Ohm's law. So I said the right answer to this is this as a quantity of electricity is measured in coulombs. The next question, I only need to talk about EMF, and PD is the amount of work done in moving a current throughout a circuit. So please note that PD, which we call voltage, EMF. So EMF is the sum total of all the potential difference that is flowing through a circuit. So there are two potentials difference or potentials. The first one is IR, this I small r. In fact, we call this lost volt. I hope you guys are there. There are lots to talk about, but we base it on what you need. So if you add all the PD, the first PD is lost volt. The second PD is what? IR, big IR. So you can see. So we can now say some people will now remodernize this one as I, they factorize R, they now say small r or big R plus small r. And this formula is one of the commonest formula you see around in your test material as an O-level student. It's common in the OKKs, the Anyakwas, and stuff like that. So E over what? R plus R. I have only made what? So this is the way we relate current in terms of EMF and stuff like that. The sum total of all the PD. This is called PD. This is called lost volt. So when you add them together, you have the electromotive force that is flowing around the circuit. Shorty concept, and that is what I am here to do. The next question. Which of the following graph correctly illustrates the relationship between current I? I guess this is I, current I, and the voltage V for a cell which with appreciable internal resistance. Now for current I against V, obviously the current is always proportional to what? To voltage, according to Ohm's law. That is Ohm's law. So just for a direct graph, I think this is just a direct question, which I've talked about in the first slide. We move to the next one. Please, let's be attentive. The next question says, in this diagram, I hope students are here. In this diagram, you can see shown by the side here, it's not above in this case, the ammeter registers a current of 2 amps when P is 6 ohms. When P is 6 ohms, and register 4 amps when P is 2 ohms. What is the value of R? Now, guys, let's look at something. Arrangement. We've talked about arrangement for capacitors. The same thing for what? For resistors. Resistors can also be arranged in series and also what? In parallel. Now, what you just need to keep in mind is just the inverse of what we've done for capacitors. So, equivalent resistance for series, R equivalence, is equals to R1 plus R2 till infinity. So, we say if there are two resistors and they are arranged in series, always keep it in mind that their current, I, is constant. Constant, I use K. The same current flows through what? Resistance bars that are connected in series. Resistor always are attached in series and potential and voltmeter are always connected to what's in parallel. These experiments should have been performed in your junior classes, and if not, most of the academy do have concept video, but it is from basics to advanced because most of the concept video for electricity are for advanced students, which is provided on the channel. You know, KVL equation and Kirchhoff voltage law, KCL equation, infinite resistor, ladder resistance, and to mention but few, unbalanced Wheaton bridge, and I have tackled all those stuff for advanced level students, and for your levels I talk about Thevenin's principles and stuff like that. So but for now we limit it on basic things, which is what I'm trying to do. So from what you have just studied, now we said V is equals to IR, Ohm's law. The same current is passing through them, but let's go through the likes of this question. It registers, we want to get the voltage, we can just set an equation just for us to see the same voltage. You can see. Now, we need to understand something. V is equals to IR. We are going to substitute the value, and because we are going to substitute the value, let's see what we are going to see. You can see they are connected directly to the ammeter. The ammeter is connected directly to what? The battery. So now let's just substitute value and say I, the first current is 2. Now the total resistance here should be P plus R because they are in series, R1 plus R2. So the current here was 6 plus, I'm looking for the value in R. I'll write it as R. That's the equivalent resistance of this. That's the first equation. The second equation, I will also use V equals to I R. What is now I for the second equation? You can see what I'm doing, my dear students. It is 4. I hope I'm not making a mistake. Then this was 2 plus R. You can see, guys, what I have done there is so simple because it is direct question. So because the cell is the same, you can see the cell are the same, we can set these two equations equal. What are the two equations? I have 2 open bracket 6 plus R as the first one is equals to 4 open bracket 2 plus R. On simplification, I can say 2 here 1, 2 here 2. So I'm going to have 6 plus R because 1 multiplied by anything is 1 is equals to 2 times 2 is 4 plus 2 times 2 is 2. 6 minus 4, I am collecting like times is equals to 2R minus R. So this will give me 2 is equals to R. So the resistance I'm looking for is 2. You can put SI units, which is measured in ohms. So please always keep that at the back of your mind. The answer to this question is nothing but option A, and that is a question answer. I hope you understand that. We can move to the next question. About the next question, we are talking about the resultant resistance, which we call equivalent resistance. Now, when resistance are open, what? Now, this is an open circuit. Now, another thing between E, electromotive force, I give the formula as I big R plus I small r, you call lost volts. Now, this is EMF is applicable for what we call open circuit. What do we call open circuit? That is circuit that is not delivering any current. You can say no current is flowing. When current is not flowing, we say open circuit. Remember, Ohm's law, current equals to V over R. So when current is not flowing, V over open circuit. Now we said that when current is not flowing, that means the resistance of this particular thing is 0. So if the resistance or infinite resistance or whatever, I said I should have gone for R equals to V over R. For me to explain from Ohm's law, I just want you to see some stuffs. Resistance is equals to PD over I. Ohm's law, Ohm's law, Ohm's law, here. Ohm's law. Please, very important. The V is V, current is not flowing at 0. Whenever 0 is under, the answer will be what? Math error, which we call infinite. So we say the resistance is an infinite resistance if it is an open circuit. A very good example is what you have seen here. It's an open circuit because I can continue to add. In A level, we call this one ladder resistance bus. Ladder resistance bus. So don't tell them I am teaching you shortcuts. There are a lot of methods we can use to solve this. Like I said, we have what we call Kirchhoff voltage law, Kirchhoff current law. But I won't use that because for a level, it is just basic questions you can answer without any law. So look at the flow of current here. Let's start. It starts like this. Like I told you when I did capacitor, these and these, because this is where I can add. I can add another bus. So anything you are adding there are in parallel. So for parallel resistance, the equivalent resistance is just equals to, you can see it is 2 and 2. Just say 2 over 2, 1. But your teacher have told you that it is always 2 times 2 over 2 plus 2. I just reverse the capacitor law that we've done. It's the same thing. So this is 4 over 4. And 4 over 4 is what? 1. So I have resolved these two now to series. So I can now move 3. What is the answer to these 2 and 2? The answer was 1. 3 plus 1 plus 4. 3 plus 1, 4. 4 plus 4 is 8. This will make the answer to be valid. So again, if you watch my capacitor, just change what you have learned in capacitor, reverse it. You are going to have what? 4 resistors. It's very simple and basic. And I told you, open circuit has what? Infinite resistance. Open circuit has what? Infinite resistance. So let's move on, guys. The next one is going to be in the next slide. Fine. In continuation to what? Open circuit. This is more or less like open circuit. You can see join. Like I told you, you can see these are in parallel. So equivalent resistance, that's equivalence is 2 times 2 over 2 plus 2. My own method, when they are the same, you know this what? You remember that R over N. R over N. R is the resistance. How many? N is how many what? How many of them? There are 2 of them, and it's what the resistance to them is to just say 2 over 2, 1. But this is always better, 4 over 4. 4 over 4 is nothing but 1, my dear student, 1. Now, another person is taught 1 over R equals to 1 over R1 plus 1 over R2. Please use it. It is the same thing. I'm only using the concept of product over sum, which is also the same thing as what. So just say 1 over 2 plus 1 over 2. When you cross multiply, you are going to get 1 ohm. Apologies because of time frame. I have to speed my movement. So now it's kind of simple now. 1 plus 2 is what? Somebody said 1 plus 2. Now you can see in this case, this bus that was added, because I've told you about infinite bus, this one and this one too are also implied because this bus was added to an infinite ladder resistance. So I can resolve this and this. I can as well resolve this and this too. So equivalent resistance in that one, sorry, I'm rushing, is also 2 times 2 over 2 plus 2. And it's also 4 over 4, which is what? 1. So what I have now, let me draw the diagram I have now. From P now, I have P. Then after P now, I have resolved these two, which gave me, the P gave me 1 here. Then I continue after the 1. I have the next one. Please, this is 1. I'm just writing very quickly. Then I have another 1, which is the combination of this and this, which has been resolved to series, is now 1. Then I have this one and this one, which also gave me 1 at this corner. So now I have the last one, 1. This is the last one. Then the last one, which was here, also has what? 1 here. I'm just trying to show you what is left. I have resolved this and this to 1. I have resolved this and this to 1. So let's start. 1 plus 1, 2. 2 plus 1, 3. 3 plus 1, 4. So the equivalent resistance for this question is nothing but what? 4 ohms. I hope you understand. That is the way we solve this type of question. And that is current electricity, talking about infinite ladder resistance. So keep it in mind. They are simple stuff you guys can deal with. Now let's go to the next question. We have 4 equal resistors R1, R2, R3, and R4 are connected in series as shown in the figure below. V1, V2, we have V3. There should be V3 and V3 are both meter connected as indicated. Which of the following relation is correct? Let's look at kind of what we have just learned. Apologies, guys. Now we said Ohm's law. From Ohm's law, we say V is equals to IR. You can listen. The resistance are equal according to them. They say it is equal. So you know what I'm going to do, my dear students. So far resistance is equal, and all these resistors are connected in series. What did I tell you about series connection? Same current will pass through them. Current is the same. So I is equals to V over R. So the same current. So let's get each of them. The first one, the current in the first one is the same thing as the current in the second one. The first one is V1 over R. They say the resistance are equal. The second current is also equal. Look at this one. The amount of what the total resistance for this one is R plus R, because they say all the R are equal. R plus R. What is R plus R? Series. R plus R is 2R. So V2 over 2R. I hope you are there. Then the third one is I, the same current we pass. That is R4. That is V3. As you can see, I'm trying to see that is V3 over R is constant. So the same current is going to pass through them. So we can set everything equal. V1 over R is equals to V2 over 2R is equals to V3 over R. What happened? R is also equal. R gets cancelled out. Cancel all the R. What do you have? You have V1 is equals to V2 over 2 is equals to V3. So this is what you are having. So you can check the expression if there's anything that looks like this. So V1 is equals to V3 is equals to V2 by 2. You can see the way I have solved that because I know concept. So that's that about that. Always use Ohm's law for any type of connection. For basic level, your questions are very clear and direct. We move to the next question. Yeah, we have resistance circuit now, or resistive circuit, the way we call it. Now, for this resistive circuit, in the figure, E is the accumulator as a battery, what potential always flow from what? Higher potential, lower potential to higher potential, from negative to positive. Electric field flows in the other way. So always keep that at the back of your mind. So then we can talk about other factors that affect resistance. Resistance is opposition to the flow of current, but that is not what I'm to solve here. Now, E is an accumulator with negligible internal resistance. If the EMF is 9, the total amount of this thing is 9 volts, 9.0 volts was passed through this thing. So we can write 9.0 volts. So the total current, what do we call current? From Ohm's law, I is equals to V over R. So what's the total V? 9. We need to get the total R. What did I tell you about this? This and these are in parallel. Let's get the total R. So for equivalent resistance in parallel, R that's the way I'm writing, equals to 5 times 20 over 5 plus 20. If you are used to 1 over 5 plus 1 over 20 equals to 1 over half, we are going to get the same answer. 5 times 20 is 100. 20 plus 5 is 25. This will give me 4 ohms. So my dear student, these two has now been resolved to series, and it was for 4 ohms. So equivalence now for series arrangement you have is now 5 plus 4. As 5 plus 4 ohms is going to give you what? 9 ohms. So my dear student, the equivalent resistance is 9. So current that will pass through them is now, voltage is 9, resistance is 9. 9 over 9, my dear students, is nothing but 1.0 ampere or 1 ampere by virtue of what you are told in your junior classes. So that is the way we solve questions, and it is looking very cheap because I am making it to what to look like that. I hope you are following, and if you have any issues, if you have any question, you can always direct your question to me. Now let's start with the next one. An electric circuit of the figure above is connected up as shown. Which of the following is the correct value of the current through 1 ohm resistor? I only need the current that pass through this. So I don't need to waste my time. I just need to know the equivalent resistance that is passing through all this one. Now, each corner, I can use my Kirchhoff voltage law, but because it's not needed for your level, like I said, and I can just use the direct method. Now, keep it in mind that each corner is a series with a what? With resultant. You can just say each of the corner. You know what I mean? Look at the way the battery is moving. I told you battery move from lower potential to what? Higher potential, as you can see. This is the way you have it. So please always keep that. It will move from negative to positive. So follow that way. So each corners of 3 ohms are in what? Are in series. So let me just do, I have, see, whenever you have a box like this, it's so simple to actually break down because the direction of the flow of current is very, very important. This minus plus. So what we do is that, I'm going to just take them in terms of box, of right angle. So I can say each corner, for example, each corners are, we talk about branches. So we can take the form one. Look at it in terms of right angle. It's a short way. I'm going to teach you. It's very, very fast. So take each of the corners at right angle here as being in series. So effective or equivalent resistance of each of them, I have to be fast. Time is not on my side. 3 plus 3, and we are taking everything in one shot, which is equals to 6 ohms. You take the other corner, it's also what? 3 plus 3, which is also what? Equals to what? Which is also equals to 6 ohms. Now, solving the two now, you can see because they are corner to corner now, you now say both of them are now arranged in parallel. That's the shortest way I can solve this for you. So for R equivalent, will now be 6 times 6 divided by 6 plus 6. I hope you get this. 6 times 6 are 36. 6 plus 6 is 12. 36 divided by 12, I think is 3 ohms. So what I'm saying is everything at this one, there is a shortcut that I've done for A-level students at a corner piece like this. It's also simple. If they are equal at the end of the day and they are in 4, it will be equals to the what? One of them. Why you don't need that. So everything in this corner now has been resolved, and the equivalent resistance is 3, which is now connected directly with 1, in series with 1. So you can now say total will now be R equivalent is now 3, the total one plus the same. Everything is now 3 connected in series with 1. 3 plus 1. Look at the way I'm writing my 1. 3 plus 1 is equals to 4 ohms. So my point is, the equivalent resistance of this box is 4. Look at the PD. The PD is 12. So from current, I is equals to V over R. What do you know? What's V? 12. What is R now? 4. What is 12 over 4? 3 ampere. So always keep it at the back of your mind. It is always very simple because questions like this is simple. Now, another thing you need to understand now is that, the question asks for the current in 1 ohm resistor. Let it be known that the current in 1 ohm resistor is the same thing as the current in this one that is in the block form. Why? Because I told you, same current will flow when something are connected in series. Same current flows in series arrangement. So just always keep that at the back of your mind. So that's the question answer. 3 is the right answer for this one. So, and that is why we are picking choice that has 3. So we move to the next slide. Apologies, guys. We have to move very fast. Capacitive circuit yet again. Now, this time around, we have to be careful. I've told you when we did our electrical cells, I always look at the way cells are connected. See, positive, negative. This is that negative, positive. So, equivalence of the what? Of the cell. E equivalent. We talk about that will be what? 2.0 minus 1.5. I talked about that yesterday during the what? Electrical cell. When cell normally they should be arranged like this, because some of you don't know this thing. Many times in classroom, my students feel this simple thing. I have to be teaching them. So if you have E1, I'm just using E now, E2, E3, and E4. The total amount of E in this one is they are arranged. You can see positive to negative, positive to negative. So everything is going to be E1 plus E2 plus E3 plus E4. This is the basis of what A level now. So you need to know that. But if they are not arranged in such a way that this is interchange, it is always subtract. As you have, look at it. This is this. Look at the way this was now. Now, if I want to get the total PD here, it will be 2 minus 0.5, which is what? 1.5, which is 0.5 volts. I hope students understand this because that is what you need to keep at the back of your mind. It's so important you keep it at the back of your mind. So now, the next thing now is just to read through the question in the given circuit of the figure above. The cell P has an EMF. Let's write down my just read EMF of 1.5 volts. And an unknown internal resistance. Internal resistance R, let's call it X for now. Teachers love using X because it is unknown. When they said Q has 2 volts and an internal resistance of, said 2 has 2 volts, okay. The second one has 2 volts, which we can see EMF of the second one is 2 volts. And internal resistance of R is 10 ohms. Is it 10 ohms or 1? Because I'm saying 1 here. I think it's 1.0 because it's what is here. So 1.0 ohms because internal resistance should be very small. That is why I was able to correct that. Please note that. So my students are the one always preparing the slide. Now, the next one is that if the ammeter is 50 milliampere, that's the total current. Current I is 50 MA. Conversion is important in physics. That is 50 times 10 raised to power minus 3. That's like 5 times 10 raised to power minus 2. That's 5 over 100. I hope you know that. So 105 is 0. 50 is 0 in 500. 5. I'm just doing like a baby way of solving. So this is the total current that flows through the circuit. So the circuit has the total current of 0.05 ampere. So that's the total current flowing through the circuit is 0.05 ampere. So now, let's quickly do it. Time is not on my side. I'm sorry. So if this is the total, then the value of R is equals to what? We have talked about when cell is connected, the total EMF is always equals to IR plus I small letter r. So the total E that is passing through this, I have just calculated that. Why did I subtract? I have explained the reason behind that. So this is 0.5. Let me factorize I into brackets R plus R. Let's do something, guys. Now, the total currents that pass through this, we know 0.5 is equals to 0.05, open a bracket, small letter R. Let's see the R. The first one has capital letter R, 7. You can see the external resistor is 7 plus internal resistance. There are 2. One has 1. I'm talking about equivalent internal resistance. The total internal resistance. When I say equivalent, I mean the total internal resistance. So you need to just keep that at the back of your mind. So the total internal resistance here is R equivalence. Now the total of the two will be X plus 1, or you say 1 plus X. Any one is correct. Because I'm adding everything in this cell. So I'll just put this one as X plus 1. X plus 1. So let me do a simple mathematics here, which is expansion. So let's do that together. I don't have calculator here, and that is what my students used to help me to do, and they are not around when I'm making this. So I have to do this all on my own, or you help me finish it. E0, I'll just take you through. I don't want this thing to cut because I have a long way to go. 0.5 is equals to, let's multiply. We are trying to expand. Maybe I show you. Is 0.05 open bracket 7 plus x plus 1. 7 plus 1 is 8. 0.5 is equals to 0.05 open bracket 8 plus x. You know we are looking for x. You can divide both sides by 0.5 to make it easy, or anyhow you know how to do it. But let me divide both sides by 0.5. Or somebody will say, I want to expand. Anyone you know how to do. If you are the type that like expansion, and say 0.05 times 8. I think that should be 8 times 10 should be 40. That's 0.4. Please correct me if I make any mistake. 0.05 times x. 0.05 times that should be 0.05 x. On simplification, you should get the answer to this. Should I leave it for you guys to finish up on the stuff? So please, you can always correct if there's any mistake. That is why I always it shows that you are following the class, and this is the best thing you can do. So it's when you now move this, it will be 0.5 minus 0.4. That's 0.1. Is equals to 0.05x. Make SOL formula, which is what you are looking for. That's 0.05 divided by 0.1. 0.1 other divided by 0.05. So I have only used my number. 1 over 5 is 2. I think the answer is 2. So please, punch calculator. My own way of doing things might be different because I don't fancy using calculator. My offline student know me very well about that. I don't use calculator. This is 2 ohms. No calculator is allowed on the screen of the exam. So that is true. And that tallies with option D. I have only solved this question with the knowledge of what? The battery, which we have talked about. The next question is going to be another type of question we call questions that falls on Wheaton bridge. Now, this is a Wheaton bridge which is used to calculate what unknown resistance. Now, one thing about basic students is that you are so lucky. Your Wheaton bridge is always balanced Wheaton bridge. So, so for balanced Wheaton bridge, my dear, so you just cross multiply. You are so lucky. So this is 20. This is W, which they ask you to look for. So 20 times W is 20 W is equals to, this is 15, this is 24. 15 times 24. Make W subject. W will be equals to 15 times 24 divided by 20. So this is the way you solve balanced Wheaton bridge. Unbalanced Wheaton bridge are different. We use KVL equation and KCL equation to break them. But for Ijmb level, for Waec level, your questions are balanced Wheaton bridge, and it's so simple for you to solve. You can break in pieces. You can say 5 can go here, 5 goes here, 3, 5 3s are 15, 5 4s are 20, 4 here, 1 4 here, 6, 3 6 are 18 ohms, which is the question answer. 18 ohms is correct for this. So D is correct for this. DD is the answer to that. We move to the next set. Now, the next set of questions talked about the resistance of wire depend on that. Now, I don't need to start deriving, but if you want concept video, watch the derivation. They are available on my channel. The resistance of a wire is given by a constant. It is even from Ohm's law. That's why I say if I want to derive, I will have to draw a metallic conductor. I talk about relaxation time of electrons. I talk about speed, drift velocity, and I talk about, all these things are for A-level students. For you guys, what you just need to pass your exam is from V is equals to IR is a famous formula you have learned in your junior classes, where R is a resistance. Now, keep it in mind that resistance of a wire is proportional to what we call depends. Please, always keep it at the back of it. It's proportional to the length. Kamelin Ohms, 1914. You don't need all these things. Resistance of a wire is inverse proportional to the area. So when we combine these two variations together, we say resistance of a wire is now equals to, we introduce a constant we call resistivity, we call rho L by A. Derivations are available on my channel for all these things. So this is the formula your teacher might have told you in your junior classes. Keep that in that. But where rho is defined as resistivity of wire. Which depends on the nature of the material. Resistivity. Apologies of wire. I'm trying to spell. Now, resistivity of wire is also said to be inverse proportional to conductivity. You might also have talked about that in your junior classes. So, per ohms. And this one, conductivity, you know, watts per meters per Kelvin or joules per seconds per Kelvin. So please keep that at the back of your mind. So that is what we've talked about. There are concept video about that, but that is not needed for now. Then again, we also talk about how temperature affects the resistance of wire. We talk about temperature coefficient of resistance. I've talked about that when I teach the heat slide under the heat transfer. I talk about Joseph Stefan and other laws, which you don't need for now. What you need now is just resistance of wire depends on length of wire, depends on area of wire, depends on resistivity. You can see direct relation, inverse relation. Inverse means the higher the one, the lower the other. Please always keep that at the back of your mind. Now, temperature also affects resistivity of wire, resistance of wire. We say the new what resistance of a wire, I've proven this before, is always the old resistance, open bracket, 1 plus alpha change in temperature. So this is how this alpha is now called temperature coefficient of resistance. Temperature coefficient of resistance. Shorty concept, which you need. That's why we call this one quick revision. After you've been to that class, this is where you do quick revision. So these are factors that affect length of wire listed, diameter of wire. Now, when you talk about area, definitely you can actually fold the wire to form a circle. There are different loops in wire. When area for what? When it forms a circle, you said area of a circle is pi r squared. And some people can say area of circle equals to, radius is half of diameter, r over 2 squared. So r over 2, that is a diameter over 2 is r. So you can also make it in terms of pi d over 4. So please always keep that at the back of your mind, area of a circle. But I'm not going to that. What I'm trying to say is that since area, wires can form different loops. It can, that means it can be what area can affect, diameter can affect, radius can affect. Please note that. So I will also take that as what can affect, yes. Temperature, I told you this is our temperature coefficient of resistance. In fact, we have what we call color coding of resistance, which I think is not in your syllabus, but for level students, you know color coding of resistance. We have talked about that, I'm not going into that anyway because tolerance rate and all those kind of stuff. Now, for now, the resistivity is also listed here. So all these factors are factors that affect resistance of wire, a quick concept. So the answer to this is all of the above, and that is correct. Please always keep it in mind. Knowing concept with me is good. But now you are doing revision. These are quick concepts you learn in milliseconds. Milliseconds. That is the way I call it. The next question, guys. An electric cell has an internal resistance of 2 ohms. Small letter R is equal to 2 ohms. I hope you remember that internal resistance is 2 ohms. A current I is current of 0.5 ampere is passed to flow it through a resistor of 5 ohms. Capital letter R is 5 ohms. What do I know? The electromotive force in it is that we've talked about this. Electromotive force is the sum total of all current, all PD flowing through a circuit. This is the simplest way. You can just substitute parameter. 0.5 is the current. Small r is 2. Big R is 5. What do I know? I can just say 0.5 multiplied by 7. Without any further ado, this is 3.5. Volt is the potential, is the unit of electromotive force, and the answer to this is nothing but choice B. So my dear students, you can see the way we are doing all these things because they look simple, because we have talked about the concept and we have an idea about what we have studied in our junior classes. So guys, we move to the next slide. Wow, the next slide, still not the last slide. Wow. When a non-standard resistor, please listen, when a non-standard resistor, please just listen, a non-standard resistor of 2 ohms, that's the resistance, is 2 ohms, is connected to the 0.0 end of a meter bleed. Now, that's another good thing. I love that. Connected to the 0.0 end of a meter bleed. I have to draw. I'll just draw anyhow because of time. Then, the balance point is found to be 55.0. What is the value of the unknown resistance? Let's draw something. 2 ohms. I would always draw my ohms resistor like this. Was connected here. This is just the way you're doing that. This is 2 ohms. then unknown value X, then this will always be connected directly to a galvanometer the way we connect it. These are just wires. For those who don't know, then we have something like, it looks like a bus like this. Just for understanding sake, that is why I'm drawing this. So we have the balance point. Let's talk about balance points. So this was connected, 2 was connected to the 55 centimeter. So 2 balances 55. How many ohms? Meter bridge 55, is it 55 or 35? 55.0 is equal to 55. So the meter bridge is always measuring the length of 1 meter. 1 meter is 100 centimeters. So if this base is 55, you can always get this yourself. Please always keep that at the back of your mind. So based on question, your questions are very simple. And that's why you can get everything in physics and mathematics. It's so simple. You understand? Even in chemistry, if you are very good. Now, if, like I said, the meter bridges measure the wire of length of 1 meter. So if this is 55, to complete 1 meter, this is what 45 centimeters. So they balance each other because we say resistance is proportional to length. That is the concept of what meter bridge. So for every meter bridge, always keep it like that. So please, or you say what R equals to K over L. So that's the way we solve it. I said resistance is proportional to length, and in some cases you say resistance is also what inverse proportional to length. So keep that at the back of your mind for a meter bridge. So let's do something, just balance them. Some people will say cross multiply. Yes, it's also going to, because they balance meter bridge as well. Simple. Some people will take it up onto each other, like 2 over 55, very good, is equals to x over 45. So you can just cancel out and cross multiply. When you cross multiply, just like what I said there, just cross multiply from here, you get your answer. So 2 times 45 is 90, is equals to 55x. Make x of your formula. X will be equals to 90 over 55. Please let me punch calculator. Let me try. This is 1, 5, that's 6. So 1.6 something, okay, 1.64. So that should be the question answer. And that is the answer to the meter bridge. So this is the concept of meter bridge. And why we are doing that is what we want you guys to score everything in your exam. That is why we are covering everything. Now the next is I think this is a potentiometer. Potentiometer. So now let's look into this. We have a question. A standard, are you guys there? A standard cell of EMF of 2 volts is connected to the potentiometer. I hope you can see, connected to a potentiometer, and the balance length obtained is 30 centimeter. When the cell is connected to the potentiometer, the balance length becomes 45. Just like what I did. Just use the same concept. Now I may not draw. 2 balances the length of 30. I'm using centimeter. Then when S is connected to the X, balances, this is voltage. Now potentiometer measures small voltage. Meter bridge measure what? Form value of what? Resistance. Please note that. Now, X will balance the remaining centimeter according to this 45. What do I know, guys? I just cut. I can cut in any way I want to cut. It depends the way I want to. Then here I cross multiply, and I'm going to pick my answer. I hope my student gets this. So please, that is the way we solve this type of question. So there's nothing to solve here. The answer to this one is nothing but what? Cross multiplication of 90 divided by 30. And that is 3. I hope you understand. So you don't need to waste time, because most of your questions, like I said, are balance, wisdom rate. They are balanced. So because they are balanced, it's very simple to solve. They are balanced. And I say balance, they are very, very simple. So note that, and we move to the next one. So the next question will be on the next slide. So we've done the same thing. Oh, wow. Most of the academic team actually gave me 3 questions together. So let's do, this is a balanced wisdom bridge. We've talked about this. 50 times R is going to be 50 R is equals to 30 times 20 should be 600. R will be equals to 600 over 50. You can see we are sorry, because we know concept. So that is 60 over 5, and that is 12 ohms. Balanced wisdom bridge, just cross multiply. Then how about this? A wire of length 15 meter made of resistivity of this, and as the resistance, determine the area. R resistance equals to rho L over A. Substitute this value and calculate the value of A. So if you do that, I will leave this for you as usual. So just put the parameter. Rho is resistivity. You are looking for area A. So do this and drop your comments in the answer, what in the booklet. Now let's talk about the last question. No option there. In the diagram below, AB represent, or I should leave it for you guys to do. Maybe I should leave it for you to do. AB represents a potentiometer wire of length 1 meter. The total length of the potentiometer is always 1 meter. I told you about that. Now, and the resistance 4 ohms. The resistance is 4 ohms. A cell of EMF 2 volts provides a steady current in the wire. If the cell with EMF 1.14 give no current when the Jupeb is at the point of P. This is the Jupeb. Okay, fine. Calculate the value of the balanced length AP. We are looking for this length AP. I just call it S there. Now let's do something. The total resistance in this circuit, we are told that a resistance of 4 ohms is connected to it. That is in series. So equivalent resistance. That's the first thing I write. Equivalent resistance is equals to 1 plus 4. 1 plus 4 is what? This is the 1 plus the 4 that is not shown. You can see what it was mentioned is 5 ohms. I have told you how we work with potentiometer. It's so simple to work with potentiometer. So we can say now, a potentiometer, we can talk about negligible but internal resistance because we are not talking about because it's there are no current. So internal resistance can be neglected. So now we can now say, let's say the current that will flow through this will now be I is equals to V per R. We've learned about that before. The voltage that is passing across this thing was 2 volts. I hope students can see this. But we are neglecting internal resistance because it's not given. R is equals to the big R is what we calculate 2 over 5. What is 2 over 5? I think that's 0.4. Please just work with what I'm doing. I'm trying to calculate the current that will flow through this box now. Now, let's now go to what we have talked about now. 0.4 ampere is the current that will flow. So EMF across AB now, AB. I want to know the amount of EMF that will flow across AB. Now, what is the formula for EMF? That is the voltage. V is equals to IR. You can see current is flowing like this. What is the current? We calculate the current 0.4 times the resistance. What's the resistance at that point? At that point, AB. We've talked about that. Look at it here. The resistance at AB represents the potentiometer of wire 1 and resistance of 4. So resistance is 4. The 0.4 times 4 is 1.6 volts. So at AB here, the potential that will flow through it is 1.6 volts. What is the length of AB? The length of AB is 1 meter. The EMF that will flow through is 1.6 volts. I want to set the formula we have learned. So that is why they think there is no option. I think it's a theoretical question. Most academic team just want me to solve it for them. I love that, no problem. So now, what you do, these are exercises you see, and you don't see options there. You don't know if you are right. You have to solve well. So to know the concept. So my point is 1.6 corresponds to 1, as you can see. So the second EMF here, the second E, this is like E1, corresponds to L1. Then E2 is 1.1 volts, will now corresponds to L2, which I love using X. So now let's do that from what we have studied. We know that 1.6 volts, 1.6 over 1 must be equals to 1.1 over X. What do I know? I cross multiply. X answer will be equals to 1.1 divided by 1.6. I don't have calculator. And dear students, 1.1 divided by 1.6. Answer should be, I don't know. Somebody is helping me. What's that? Okay, fine. Thank you. 0.6875 meter. So guys, that is all about this. That's the answer. You can convert to centimeter, the option and centimeter. And look at the way I've done this, mixing the concept of V equals to IR with other concepts. And that is where we are going to stop. Now, this is where I'm going to stop for this section. See you guys soon tomorrow where we'll talk about RC circuit. That is electrical heating effect of current. Talking about your power and stuff like that. We're talking about electrical power and distribution of power. So guys, if you find anything interesting on this section, do what? Subscribe to the channel and share the content with your friend that you know they are attempting physics in their forthcoming examination. And I gave you work to do. You can always drop the comments, answer down there when you watch the video. So see you guys soon. Take care and be blessed. Bye for now. Thank you.